Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to solve the numericals on rectifier circuits. A numerical of power supply, that is rectifier circuits. So first numerical. In half wave rectifier, the secondary voltage is 25 volt. Calculate DC load voltage and load current for load of 20 ohm. दिस क्वेश्चन इज फॉर 3 मार्क्स. मी तुम्हाला बोर्डाला हा क्वेश्चन 3 मार्कासाठी पडलेला, तो मार्च 2001 ला पडलेला क्वेश्चन. तर 3 मार्क्स पैकी 1 मार्क्स फॉर फॉर्म्युला. मी तुम्ही फॉर्म्युला जर मेन्शन केलं लिहिलं तर तुम्हाला ॲटलिस्ट 1 मार्क्स मिळणार आहे. आणि सॉल्व केलं की तुम्हाला 1 मार्क्स कॅल्क्युलेशनला आणि 1 मार्क्स तुम्हाला मिळणार आहे आन्सरसाठी. आता याचं आपण सोल्युशन्स बघूया काय आहे. डाटा तुम्हाला दिलेला आहे. व्हॉट इज डाटा? VS इज गिवन, दॅट इज 25 volt. Then RL, that is the load resistance, is given, that is 20 ohm. And we have to find out VDC, that is known as the average voltage, or it is also known as the load voltage, that is VDC. And we have to also find out the load current or DC current or average current, or it is also known as the output current. So solution. आता आपण न्यूमेरिकल पेपरवर सॉल्व करतोय. ओके, व्हॉट इज युअर डाटा? इथे डाटा परत मार्क करू आपण. VS, दॅट इज 25 volt. RL, that is given 20 ohm, and we have to find out VDC and IDC. Now solution. What is the solution? The formula for VDC, that VDC is equal to 0.318 into VM. But what is VM? VM is equal to 1.414 into VS, that is secondary potential. So by substituting the value of VS, 1.414 into VS, that is 25. So that is equal to 35.35 volt. That is known as VM. So VM is equal to 35.35 volt. We have to find out average voltage or output voltage, that is VDC, is equal to 0.318 into now 35.35. So that will be equal to 11.2413 volt. That is our first answer. 11.24 volt, that is our first answer, that is VDC. Next we have to find out load current. Load current, that is IL, that is also known as IDC, and that is given by VDC upon RL. That means we have to use Ohm's law. VDC upon RL. Now what is VDC? It is 11.2413 upon RL, that is 20 ohm. So that is equal to 0.562 ampere. Why it is in ampere? Because voltage is in volts and load resistance is in ohm. So it is 0.562 ampere, or it is also written as 562 milliampere. So our IL is equal to 562 milliampere. So these are our two answers. VDC is equal to 11.2413 volt and IL is equal to 562 milliampere. आपण परत एकदा बघूया कसं सॉल्व केलं. VS is given, that is 25 volt, RL 20 ohm, VDC and IDC आपल्याला कॅल्क्युलेट करायचे. What is solution? VDC is equal to 0.318 into VM, but VM is equal to 1.414 into VS. So by substituting the value of VS, we are getting 1.414 into 25, that is equal to 35.35 volt. Now by substituting the value of VM, we get VDC is equal to 0.318 into 35.35, that is 11.2413 volt. That is our first answer. Now we have to find out IL, that is load current, or that is known as the IDC, that is given by VDC upon RL. In this case, we have to use Ohm's law. So 11.2413 upon 20, that is equal to 5.562 ampere, or it is written as 562 milliampere. That is our second numerical, second answer. Now we are moving toward the next numerical. What is our next numerical? In full wave rectifier, center tap transformer is used. The secondary voltage is 50 volt AC. Using ideal diodes, calculate the DC load voltage, current rating of diode, PIV rating of diode, and given RL is given, that is 47 ohm. So this question is also for 3 marks. 1 mark for formula and 2 marks for calculation. Now answer. Solution. Data. What is data? Vs secondary voltage is given, that is 50 volt. Next, RL is given, that is 47 ohm. We have to find out VDC, that is average voltage, load voltage, output voltage. Then IO, current rating of diode, and PIV of diode used in this circuit. So now we are going to solve the numerical. So friends, data. What is data? Vs. Actually that Vs in this case center tap transformer is used. So VPP is given, peak to peak voltage, and that is 50 volt. Secondary voltage, that is 50 volt. Then RL is given, that is 47 ohm, and we have to find out VDC, then IO and PIV. We have to find out VDC, IO and PIV. So now solution. VPP is given, that is 50 volt, and we have to find out the peak voltage. The secondary potential developed across any half of secondary of transformer, that is given by VPP by 2, so it is 50 upon 2, so it is 25 volt. That means Vs secondary potential Vs1 आपण त्याला Vs1 म्हणूया और Vs2 म्हणू, that is equal to 25 volt. We have to find out average voltage. The formula for average voltage or VDC is equal to 0.636 into Vm. It is now 0.636 because it is a full wave rectifier. So 0.636 into Vm. But once again, Vm, it is a maximum secondary potential developed across any half of secondary of transformer. So that is given by 1.414 into Vp, or it is a Vs1 or it is a Vs2. So it is equal to 1.414 into 25. So it is 35.35 volt. That is our maximum secondary potential developed across any half of secondary of transformer. Now by substituting this value, we get VDC is equal to 0.636 into 35.35. So it is 22.48 volt. That is our first answer, VDC. So VDC is equal to 22.48 volt. Next we have to find out PIV. What is PIV? It is a peak inverse voltage, maximum reverse voltage, and PIV is equal to 2Vm. Actually PIV is greater than or at least equal to twice that of maximum secondary potential developed across any half of secondary of transformer. So it is, that means PIV is greater than equal to 2 into 35.35. So it is 70.70 volt. That is our second answer. 70.70 volt is our PIV of our diodes used in these rectifier circuits. Next, we have to find out IO. We have to find out IO. But before that, we have to find out the load current, IDC. So IDC or IL is given by, once again, Ohm's law is used. So VDC upon RL, what is VDC? It is 22.48 upon what is RL? RL is equal to 47 ohm. So the answer, the calculation, the answer is now 0.4782 ampere, or it is 478.2 milliampere. That is our IDC. But we have to find out load current. Sorry, we have to find out current rating, IO. So friends, IO is given by IO is greater than or at least equal to half the DC load current. So it is given by IO is greater than or equal to IDC by 2. So it is greater than equal to, what is IDC? It is 478.2 upon 2. So this answer is 239.1 milliampere. So that is our current rating. So first answer, the average voltage or output voltage is 22.48 volt. PIV is 70.70 volt and the current rating of diode is 239.1 milliampere. So this is our answers. Okay. Now we are moving towards the next numerical. आपण पुढच्या न्यूमेरिकल जाऊया. तिसरा न्यूमेरिकल. In full wave rectifier, the secondary voltage is 20 volt. The secondary voltage is 20 volt. Using ideal diodes, calculate the DC load voltage and load current and current rating of diodes given RL is equal to 100 ohm. This question is also for 3 marks. 1 mark for formula and 2 marks for calculation. Okay. Now answer. Data. What is the data? Data Vs is given, that is 20 volt. RL, that is 100 ohm. We have to find out VDC, IL and current rating of diode. Okay. Now we are going to solve this numerical. First of all, data. What is data? Vs, that is given 20 volt. RL is given 100 ohm and we have to find out VDC, IDC and IL. Solution. VDC. What is VDC? VDC is equal to 0.636 Vm. But once again, Vm is maximum secondary potential. It is given by 1.414 into 20 into 20. So it is equal to 28.28 volt. That is our maximum secondary potential developed across secondary of transformer. Now VDC. So it is 0.636 into 28.28. 0.636 into 28.28. So this is 17.98 volts. So this is our first answer, VDC. VDC is equal to 0.636 into 28.28. So it is 17.98 volt. That is our output voltage. Next, we have to find out IDC. So IDC is equal to IL. It is given by, once again, Ohm's law is used. So VDC upon RL. So what is VDC? 17.98. 17.98 divided by 100. So it is 0.1798 ampere. It is ampere. It is in ampere. So it is equal to 179.8 milliampere. So IDC is equal to 179.8 milliampere. That is our second answer. Now we have to find out the current rating, IO. So current rating of this diode is also given by IDC by 2. It is half that of load current. So what is IDC? It is 179.8 upon 2. Sorry. So it is 89.9 milliampere. So current rating of diode should be greater than or at least equal to 89.9 milliampere. That is our third answer. So friends, these are the numericals on a rectifier circuit. That is half wave rectifier, full wave rectifier and bridge rectifier. In our next video lecture, we are going to study the numericals on regulator circuit. So friends, thanks for watching this video lecture. Bye. Take care. See you again in our next lecture. Bye.